Hello everyone. Okay, so in this lesson I want to show you how to construct the total cost and average cost family of curves for a pure monopoly. But to do that, first we have to review what's going on with the demand curve. So you might remember from earlier in the semester that there's a relationship between the demand curve, total revenue, marginal revenue, and elasticity. So I'm going to review that with you two ways. First by graphing them out and then showing them to you in Excel so that you can see how they work. And once we do that, we will apply them to the graphs to see how a monopoly looks with the total cost and average cost family of curves. Okay, what you see in front of you is a demand curve, and I've gone ahead and drawn it out, and I've given you these 2 points. So the y-intercept is 50 and the x-intercept is 100. So from the equation y equals mx plus b, or translated into economics, price is equal to m times quantity plus b, it would be like this. P, price, is equal to the slope of this thing, and its slope is rise over run. So from here to there, the rise is minus 50 and the run is 100. So the slope is minus 50 over 100, or minus 1/2, times q, plus the y-intercept, which is 50. So this is the equation for our demand curve. Now you might remember, and I will show you in a minute in Excel, that the total revenue curve, which is defined to be P times Q, total revenue is P times Q, will start here because when we're way up here at this very high price is 50, so this number is 50, but Q is 0, so P times Q is 0. And then as we go down to 49 to 48 to 47, or more properly as we go out this way from 0 to 1 to 2 to 3 to 4 to 5, Q is getting bigger and P is going down. But at first total revenue rises, it maxes out dead square in the middle, and then it falls again like that. So total revenue for a monopoly firm has this weird shape. Also, you might remember from our chapter on elasticity that when you have a linear demand curve, the demand curve can be separated into 2 equal parts. The top part, which is elastic, and the bottom part, which is inelastic. And that's where the total revenue test comes from that you might remember from test 1. And it had rules like this. If when the price goes down, say from 49 to 48, and total revenue increases, which it would do there, then you must have been in the elastic part of the demand curve. On the other hand, if when the price goes down, imagine you were down here somewhere and the price went down, so you're over here on the demand curve, total revenue over there is going down, therefore you must have been in the inelastic portion of the demand curve. Now the last thing to realize is, what is marginal revenue doing? So marginal means extra, so marginal revenue is extra revenue that you get each time you sell one more unit. So we'll do it in Excel in a minute, but there is a rule that you can remember. Marginal revenue has this point in common with the demand curve and falls at twice the rate. It's a very good rule. Marginal revenue has this point in common with the demand curve and falls at twice the rate. So if the demand curve falls such that it hits at 50, I beg your pardon, it hits at 100, and marginal revenue is falling at twice the rate, marginal revenue is going to hit at 50. And so that's the relationship between a demand curve, marginal revenue, total revenue, and elasticity. Now what I'd like to do is show you that same thing in Excel. So here's Excel. Okay, so from our formula, then the price would be equal to minus 1/2, 0.5, times the Q value, which is right there, plus the y-intercept, which was 50. That's just the equation. P equals minus 1/2 times Q plus 50 that we already worked out. So there's our first value for P, and then you can copy it down and you can kind of see what's going on. P is going down by 50 cents each time, all the way down to here, right? So there's our P and Q values, and then of course total revenue is simply P times Q, so it's that number times this number. So at first total revenue is 0, and you can see at first it's going up. Look, it's rising, and it will rise, and it will max out eventually, and it will fall again to 0. See that? Now it should be, if I'm correct, if that price is 50, it should be that total revenue is maximized at 25. So let's scan down to 25. Here's 25, and there's total revenue of $12.50, and that's right, that's the highest it ever is. Total revenue starts at 0, it maxes out exactly halfway down, and then it falls back to 0 again. Now, what is the last? Oh, let's do marginal revenue. So there's two ways to do marginal revenue. One way is to do it in algebra, and the other way is to do it in the calculus. Let's just do it in algebra here since this is Excel. So marginal revenue is not defined for this first square because we don't have a marginal revenue above it. But for here, marginal revenue is just the difference in total revenue from what we have now and what we had before. So marginal revenue of the first unit is $49.50, and then marginal revenue of the second unit is $48.50, and so forth. You'll notice that the price is going down by 50 cents every time. See that? But marginal revenue is going down at twice the rate. It's going down by $1 each time. It should be that marginal revenue will finally be 0 when we get down to a price of 25. Let's see if that's true. Yeah, check it out. So here, it's positive, it's 0.5, and then it's negative 0.5. The reason it's not dead square 0 here is because we've done this using discrete points, in algebra. We haven't done it in calculus. If you ask me, I'll generate another lesson to show you how this is proved that marginal revenue falls at twice the rate and has that point in common with the demand curve. I will show you that in calculus, but for now this is good enough. Then what is elasticity? Well, elasticity is 1 over the slope times P over Q. The slope in this case was minus 1/2, so 1 over the slope would be minus 2, right? Then times the P value divided by the Q value, and in this first case division by 0 is not going to work, right? But let's see if it will allow me to just bring it down to here. Yeah, so there we have a really big number. Remember, in elasticity you ignore the sign, so that's very, very elastic, and as we come down it's still elastic, ignoring the sign, right? But they're getting smaller and smaller. And if I'm right, they should go inelastic when we get down beyond a price of 25. So let's see if that's right. Here's the price of 25, right? And beyond that, it's inelastic. See that? And we could go all the way to the end, and I think it's perfectly inelastic down here at 0, and I'll give it a value of 0. Yeah, there you go. Okay, so we could sketch these out if you want, and but I don't think I'll do it in this lesson. I'll let you practice that. But you could use the graphing functions to plot out the demand curve, and right underneath it plot out the total revenue function and the marginal revenue function. Alright, I hope you find that helpful. So now we have the sketch of the cost curves, and we want to apply the ideas of a pure monopoly. So remember that the revenue function for a monopoly doesn't look like the straight line that we had for pure competition. Remember, under pure competition we had the straight line because they were price takers. They just took whatever the price was set by supply and demand. But in this case it doesn't do that. What it does is it starts at 0, it goes up, it's maximized, and then it falls again. Total revenue, right? Now this is the demand curve from supply and demand, and what you have to realize is that for a monopoly there's no such thing as a supply curve. There's no supply curve. There's only the demand curve. So all you do is you just take the demand curve, you copy it from here, and you just paste it over in this picture. So I'm just going to do that the best I can, something like that. And now I have to draw the marginal revenue curve, and you have to remember that rule. Marginal revenue has this point in common with the demand curve and falls at twice the rate. So if this demand curve hits here, for example, then marginal revenue is going to hit at half the distance, which is roughly about here. So marginal revenue has this point in common with the demand and falls at twice the rate, something like that. Now, how do we find Q star? Well, in the total revenue graph, it's really easy to see. You're just searching for the greatest vertical distance between total revenue and total cost, and I think it's right about here. It's kind of hard to see Q star. One thing you have to watch out for is a lot of times students will think it's at the tip top of the total revenue function, and no, it isn't there. It's always to the left of there. Can't be at the top because you got to think about this cost function is rising all the time, and when you're on the tip top of total revenue, it's completely flat. So you could always do better by backing off a little bit back to the left. Total revenue would hardly fall at all, but total cost would be falling quite a lot. So you're looking for the place over here where the slope of the total revenue function and the slope of the total cost function are the same. Now to find Q star in this picture over here, you apply the rule that we applied before. That is, profit maximization occurs where marginal revenue intersects marginal cost. That's right here, where marginal revenue intersects marginal cost. And then all you do is you go straight up from there until you hit the demand curve and over, and that's P star. That's the profit maximizing price. So in the case of a monopoly, you really have to search for two things. You have to search for the profit maximizing output and the profit maximizing price. Okay, so if we put numbers in here, for example, if I just made up some numbers and I said this was 500 and I told you this number over here was 12,000, then I could figure the selling price by just taking the 12,000 and dividing it by 500, and I could get the selling price as $24. So that would be this number over here. By the way, if that's 5,000 right there, this is also 5,000 over here. Excuse me, 500. If that's 500, this is 500 over here. Now, if I tell you that the average total cost, that's right here, right? Read off the average total cost curve. If I tell you the average total cost is, let's see, this number was 24, right? If I tell you the average total cost is 20, just kind of making up that number, can you tell me what this number is over here? Yes, you can, because this number over here is the total cost, and if the average total cost is 20, that is $20 per unit, and you made 500 units, then your total cost must have been 20 times 500, or 10,000. So this number right here is 10,000. And that shows me that our total economic profit is 2,000. Can you see that? But over here, our economic profit looks like $4. The price was 24 and the cost per unit was 20, $4. But that's the profit per unit, right? So how do we get from $4 profit per unit to $2,000 total profit over here? The way you do it is $4 of profit on each unit, and we sold 500 units, $2,000. Okay, I hope you found that helpful. Good luck.